Today we're going to be kicking off lesson 2 on slope. Our objective is to use tables and graphs to find the slope of a line. Slope is something that we're going to be talking about throughout this whole chapter, so it's important that we get a good understanding of it. So the term slope is used to describe the steepness of a straight line. Slope is the ratio of the rise or vertical change to the run or horizontal change. I'd like to get this definition in your science notebooks, please. So slope is the ratio of the rise or vertical change to the run or horizontal change. And you'll hear me say this quite a bit throughout the unit: rise over run, rise over run, rise over run. Once we go through a few examples, it'll make sense. So today we're going to talk about finding slope using the graph or table. And this should sound familiar. Slope is a rate of change. We've been looking for the rate of change in tables and graphs over the past few days. An important thing to note is that slope can be positive, which would be slanting upward, or negative, slanting downward. So I'd like you to get this into your notes as well. We can tell by the slope of a line if it's positive or negative by looking at the way it slopes or the way it points. So if the line is facing upward to the right, it's positive. If it's facing downward to the right, it's negative. Once again, slope is rise over run, which is the vertical change between any 2 points, and the horizontal change between any 2 points. So here's an example. We're going to try to find the slope of this treadmill. So our equation is slope is rise over run. We've got a rise of 10 and a run of 48. So our slope is 10 over 48. Now we have to simplify that as best we can, and we divide each of those values by 2, and we get 5 over 24. So our slope is 5 over 24. We just simply took this pair of values, and again, our rise was 10 inches, and our run was 48 inches. Turned that into a fraction, 10 over 48, simplified by dividing each by 2, and we had with our final answer for our slope, 5 over 24. So for example, A here, a hiking trail rises 6 feet for every horizontal change of 100 feet. What is the slope of the hiking trail? So our horizontal change is our run, and our rise is obviously our rise over run. So we have a rise of 6, and we have a run of 100. Again, we get that value, and we have to simplify them as best we can. We simplify it down to 3 over 50. So our slope would actually be 3 over 50. We're just looking at that ratio of vertical change over horizontal change. For example 2, we'll look at finding slope from a graph. The graph shows the cost of muffins at a bake sale. Find the slope of the line. So what we need to do is choose 2 points on the line. The vertical change is 2 units, and the horizontal change is 1 unit. So we choose 2 points. Here we've got 2, 4, and 3, 6. Our slope is rise over run. If we work between these 2 points to get from point 2, 4, we go up 2 and over 1 to get to point 3, 6. So our rise is 1, 2, and our run is 1. Rise over run is 2 over 1, so our slope is actually 2. We can also take the change in y over the change in x. We can take 6 over 3, we divide that out. Rise over run, y is our rise, x is our run. So we get 6 over 3 is equal to 2. And the same with this point, 2, 4. 2 is our horizontal change, 4 is our vertical change. So we could take 4 over 2 and divide that out, and we would get the same slope of 2. So now we're going to take a look at how to find the slope from a table. The table shows the number of pages Garrett is left to read after a certain number of minutes. The points lie on a line. Find the slope of the line. So now we're going to choose any 2 points from the table to find the changes in the x and y values. So again, we need to find the change in y and the change in x. We can find the change in y by just subtracting 2 of the y values, just like we used to skip count. So we'd be 12 minus 3 is 9, minus 3 is 6, minus 3 is 3. And then we're going to also take a look at the change in x. And we've got an increase here. 1 to 3 is an increase of 2, plus 2 to get to 5, and plus 2 to get to 7. So we could use the points 112, so 112, and 39, 39. Remember, it's change in y over change in x. Here's that equation looks like. So its slope is equal to change in y over change in x. And it's listed here as well. So what we're going to do is take this value, 9 for y, and this value, 12 for y, and subtract them. Then we're going to take this value, 3 for x, and subtract this value, 1 for x, and subtract them as well. What's really important to note, we have to take the corresponding pairs. So we took 9 and 3 right here, and we took 12 and 1 right here. We subtract, we get 9 minus 12 is negative 3. 3 minus 1 is 2. Our final answer, we have a slope of negative 3 over 2. And to check this, we can choose any other 2 points from the table and find the slope. And if it's a constant rate of change, we should get the same answer. So let's take a look at a couple more examples. For B, we're going to find the slope from a graph. So remember, slope is rise over run. I use any 2 points. These are the 2 points that are given. And I just find my rise over run. So I start at this point. I count up 1, 2, 3. So from here to here, I've got a rise of 3. And then I count my run, which goes from this corner to this point, and I get 1, 2, 3, 4. So my slope is just simply 3 over 4, rise over run. I know it's a positive slope because the line is going upward to the right, and that means it's a positive slope. For C, I'm going to look at finding the slope by pulling 2 sets of coordinates. Remember, I have got my y values here and my x values here. And another way to find slope is the change in y over the change in x. And we can write that more specifically by saying y2 minus y1 over x2 minus x1. So we can just give these names. We can say 1 is going to be y2, 6 is going to be x2, 0 is going to be y1, and 2 is going to be x1. So we just set up our equation. Slope is equal to y2 minus y1. So I've got y2 here and y1 here. So I've got 1 minus 0. And then x2 minus x1. x2 is 6. x1 is 2. So when I subtract, 1 minus 0 is 1. 6 minus 2 is 4. My slope is 1/4. So I'm going to help you get going on the assignment by going through an example. I chose a lesson to reteach because it's got the definition of slope, the equation that you need, and a real nice example, 2 examples actually, to help you walk through the process. So to get things started, I'm going to be using this equation. M, which is slope, is equal to y2 minus y1 over x2 minus x1. So first I'm going to name my points, my coordinates, by calling 0, 1, x1, y1, and 3, 4, x2, y2. and then I set up my equation. M is our variable that we use for slope, so slope, which is M, is equal to y2 minus y1 over x2 minus x1. So now I just take my values. So I'm going to say slope M is y2 minus y1, so 4 minus 1. And that is over x2 minus x1, so 3 minus 0. I simply subtract. 4 minus 1 is 3. 3 minus 0 is 3. When I divide 3 over 3, I get a value of 1. So my slope for number 1 is just simply 1. So you're going to use the same process as you work through the next 5 examples. Please make sure to share all of your work, just like I did right here. Label your points, x1, y1, x2, y2. Then set up the equation y2 minus y1 over x2 minus x1. Calculate your values and come up with your final answer. So you can see here, the mathematical portion of this is not real difficult. It's just a matter of understanding the equation and knowing how to label your points so that you can plug them into the appropriate place. So I'll get you started here by calling 1 x1, negative 2 y1, and then d3 x2, and 2 is y2. Take your time and use your notes and you'll do fine.